Sharing with you a live class with my brilliant student Akshit, who has been scoring 100% marks. If he can score 100% marks, you can also do it. In this video, you will learn about Cartesian equation of line from basic concepts to practice test questions. In case you want to learn from me, you can join my classes by sending an email on the address given. Let us enjoy the journey of success. Hi Akshit, how are you doing?
Hi, sir. I'm doing great. How are you?
Very good, very good. Okay, so today, what do you want to do?
Sir, today I was hoping we can look at the Cartesian equation of a plane.
So you have understood the parametric equation, vector equation, symmetric equation, correct?
Yes, sir.
Yes. So let's talk about Cartesian equation. In many aspects, it's unique, and we'll see why it is unique. That's another very important thing to understand. So let me share with you a whiteboard, and then we'll begin from there. So we're talking
Yes, sir.
about Cartesian equation of line. In R2.
Yeah.
Now, we should remember that Cartesian equation of a line is only possible in R2 and not in R3.
Yes, sir.
So at the end of this session, you need to answer my question. Why do we have Cartesian equation of line only in R2 and not in R3? Is it clear to you?
Yes, sir.
Okay. So we'll begin by saying what is Cartesian equation of a line in vectors. Okay. So the Cartesian equation is written like this: ax plus by plus c equals to 0. So this is Cartesian equation of a line in R2. Do you get the idea? That
Yes,
is
sir.
what it is, right? Now this is also called scalar equation.
Yeah.
So we say sometimes scalar or we say Cartesian equation. Okay. Now, have you seen this equation earlier for line?
Yes, sir, I have.
You have. You know standard form of line
Yeah.
equation. So when you read earlier, you know what is standard equation, right?
Yeah.
You say ax plus by plus c equals to 0. Correct. Both are same things, right? The only thing is
Right.
we are not talking about vectors, so we'll consider vectors, and more or less it is similar to what you learn in the Cartesian plane, right? This
Right.
standard form of equation, correct? So because this is familiar to you, let me begin from here. So it's a good idea to begin from what you know to the new topic and how they relate to one another. After all, it is the same line, right?
Right.
So let us say begin by saying that we have an equation of a line. So let me write down equation of a line, which is, let's say, 2x minus 3y plus 6 equals to 0, right? Purposely,
Right.
I'm taking 6 to avoid fractions. Now, if this is the equation of a line, in that case, can you find slope of this line?
Yes, sir. You can rearrange in terms of y.
Correct. So let's rearrange. So we get 3y equals to 2x
2x plus
plus
6.
6 and y equals to 2 over 3x plus 2, right? 6 over 3.
Right.
So when you write like this, you know that this slope, which is
2 over
equal
3.
to 2 over 3, and the y-intercept is 2, right?
Right.
Correct. Now, if we sketch this line, you can also find the x-intercept, right? So what is the x-intercept for this line? The x-intercept for this line will be, you plug in y equals to 0, right?
Yeah.
And then minus 6 divided by 2 gives you minus 3. Is it okay?
Yes, sir.
So that means if I want to sketch this line, a very simple way of sketching the line will be that we know x and y intercepts, which is 2 and minus 3. And so we can draw our line kind of like this, right?
Right.
Where the x-intercept is -3 and the y-intercept is 2. Is that clear to you?
Yes, sir.
Perfect. So that is your equation. We started with the standard line, and we know this is like x-axis, that is the y-axis, and that is how the line 2x minus 3y plus 6 will look like. Perfect, no problems.
Yes, sir. Got it.
Now, let's get back to vectors and see how does it relate to this particular line. Now, I would like to draw your attention to one very important thing here. We know that the slope is 2 over 3, right? If
Right.
slope is 2 over 3, then what is normal perpendicular to slope?
-3 over 2.
Minus 3 over 2. Do you notice that this is -3 and this is 2?
Yeah.
That means if I am saying these two are equivalent equations, in that case, what is normal? Normal vector will be what? So normal
Sir,
vector, yes, AB,
so
right?
yeah.
Because this is the direction X, this
Right.
is the direction Y. Is that clear to you?
But sir, in this case, it will be the perpendicular version, right?
Yeah, normal. So
The normal, right?
yeah, for this normal -3, 2 will really mean that change in Y is 3 and change in X is 2, right? So I'll
Right.
go 2 and then 3 and so here. So I get something which is like this. Is that clear to you? Which will be normal
Yes,
to
sir.
this. Is that clear to you?
Yeah.
So let me draw a line which is going from the center and is normal. Is it okay?
Yeah.
So normal really means that it is going to be perpendicular to this line. Correct?
Right.
Now let's have a look at it. This particular line, let us say, is d distance away from the origin.
Okay.
A line which is d units away from the origin will be unique, right?
Right.
Because this point is defined now, right? And we know the slope,
Yes, sir.
which is -3 over 2. You get
Yeah.
the idea. So that actually helps us to get the equation, the Cartesian equation in vectors. Okay?
Yeah.
So anyway, you got a good connection that in ax plus by plus c, a and b represents normal to the line. Is it okay?
Yes, sir.
Perfect. So let me clear the screen. Everything is good?
Yes, sir. Got it.
Now, let us look into the equation of the line again. So I'm again sketching kind of similar thing. And we'll develop the equation in vectors.
Yeah.
So let's consider a point. Let's say this point here is any given point, x0, y0. We are given a point, right?
Right.
And let's take a general point because any point here, if I know the 2 points, I've defined the line, right?
Right.
So let's say this point here is P, and then we have a point Q, which is some general point XY, right?
Yeah.
So what is the direction vector?
So it'll be from P to Q, right?
Yeah. Will be what?
X minus X naught and Y minus Y naught.
And now we want to develop the normal, the Cartesian equation. And with Cartesian equation, we understood one thing, that A and B were normal, right?
Right.
So let us say somewhere this is normal to the line. Is it clear to you?
Yeah.
So we are saying that this normal has a vector AB.
Right.
So we are saying normal is vector AB. In that case, PQ dot normal should be equal to what? 0, right?
0, sir. Yeah.
So we know that normal dot PQ should be equal to 0. And normal is AB, right?
Yeah.
So let's do the dot product. So we know that AB is, let me take this, okay. So we have AB the normal vector, let's call this as n, right? Normal vector to
Right.
the line PQ. So their dot product should be equal to 0, right?
Right.
So let's do that. So we have 8. When you do that, then we get a times x minus x0 plus b times
Y
y
minus
minus
Y0.
y0 should be equal to 0. Correct?
Yes, sir.
So let's open the bracket. So if you open the bracket, you get ax minus ax0 plus by minus by0 equals to 0, correct?
Correct.
Let's rearrange. We have ax plus by. X and y are unknown. How?
Yeah.
We know the normal vector and we know this original point P, right? So
Right.
minus ax0 minus by0 equals to 0. Is it okay?
Yes, sir.
Since these three things are known to us, a, b, x, and 0, it's a constant. It doesn't change.
Okay. Yeah.
So we can now write this as ax plus by plus c equals 0. Do you see
To
that?
0. Yes, sir. And this is our general form, right? For
This
the
is the
Cartesian
general
equation.
form where the normal to this particular line is the vector
AB.
AB. Is that clear to you?
Yes, sir. Got it.
You understand the concept of normal, right?
Yeah.
Now, to this line, we can have many normals, right? Because
Right.
any scalar multiple of k, scalar multiple of n will be normal to it, right?
Yeah.
So even k times n will be normal, right? Because some will
Right.
be smaller, some will be greater. Do you see that?
Yes, sir.
So each kn, so we have infinite normal vectors.
Yes.
Is that clear to you?
Yes, sir.
So actually speaking, even these could be normal, right? But when we use
Right.
origin as the tail of the normal, we call actually this has a special name. It's called normal axis.
Okay. Only if it's coming from the origin?
Yes. So when we, roughly say normal vector, we like to place it at the origin, like a position vector. You
Yeah.
understand?
Yes, sir.
But, in vectors, the position is not fixed. So one could say infinite is because we could have many normal vectors, right? But
Right.
the question really is that infinite normal axis. Is that
Yeah.
clear? So because you could have different lengths for this particular vector. Vector has dimensions and direction, correct? So length,
Correct.
magnitude, and direction. Direction is fixed,
Yeah.
but the magnitude could be different. That gives you infinite normal axis vectors for any particular line. Is that clear to you?
Yes, sir.
How? Whatever you may do, this equation of line is always fixed,
Yeah.
right? So is this concept clear to you?
Yes, sir. Clear.
So what we learned here is that ax plus by plus c equals to 0 is Cartesian equation where n, the normal vector, is AB. Is that clear to you?
Yes, sir.
Now, why are we saying this is a unique line when we can have infinite normals? This is another important thing to do, right?
Right.
So let's give some values, right? A and B as, let's say 1 and 2. Okay. So just write 1 and 2. So we have like x plus 2y. Let's say this is something like 5. Is okay? E goes to 0. Just give random values. So this particular line, we know the normal vector here is 1, 2. Is it okay?
Yeah.
Can you write scalar? This is scalar equation. Can you write vector equation for this?
Yes, sir.
How? Tell me.
Sir, so if this is the scalar, right, then it would have to be multiplied by something that's a vector, right? In order for it to be a vector equation?
Oh, the name we say scalar, but it is a equation for vector because the direction is a vector, normal, right?
Right.
Okay,
So then,
tell
sir,
me. But we know vector equation, we know parametric equation, we know symmetric equation, right? We can
Right.
convert one form of the equation to another form. Now,
Right.
what we are going to learn now is convert Cartesian to vector
Yeah.
or parametric equation or symmetric equation. Is it okay?
Yes, sir.
Let's do this exercise.
Yeah. Sir,
So,
quick
yeah,
question. In R2, do we have symmetric equation?
yes, we have.
We have, right? Okay.
Okay. So now tell me, Cartesian equation is given to you. How will you write the vector equation?
Sir, we can find a point, right? And then find the slope and rewrite.
Yes, you can do that. But you know the normal, so you know the slope, right? So
Right.
since the normal is 1, 2, right?
Yeah.
So the slope will be
2 minus 1.
2 minus 1. So you know that, right? Now the
Yeah.
thing is, you have to find a point, right?
Right.
You can put some value for y and calculate x.
X. Yeah.
Correct? So let's say y equals to something. Let's say 1. Okay.
Yeah.
Then x will be what? X will be equal to, let's say,
Minus 7.
yeah. So we'll substitute this in this equation, right? And solve
Right.
x. So x will be equals to minus 7. Is it okay?
Yeah.
So we have a point which is minus 7, 1. And therefore, the vector equation will be R. The vector equation will be, you can say, minus 7, 1 plus t times
T times
the
2 minus 1.
2 minus 1. Is that equation? We got one equation, right?
Yeah.
You can find some other point, put y equals to 0, for example, right?
Yeah.
If you put y equals to 0, the other point could be minus 5, right? So you can
Right.
also write
Yeah.
minus 5, 0 plus t times 2 minus 1. That is also a vector equation. Is it okay?
Yes, sir.
So you have multiple vector equations
Yeah.
because each of these vector equations is defined using any point, right? So different
Right.
points will give you different equations. However, the Cartesian equation is unique, right?
Right.
So that is very important thing to understand. And now, once you get the vector equation, can you tell me how will you get the parametric equation?
Yes, sir. Then we can simply just say that x is equal to minus 5 plus 2t. And y is just minus t.
Correct. So you got the parametric equation, right?
Right.
And how do you get the symmetric equation?
Sir, we can say that x plus 5 over 2 is equal to 1, right?
Yeah, which is equal to minus y in this case. Do you see that?
Right. Yeah.
So forget t, equate this, and you get the symmetric equation, correct?
Correct.
So that is how you can actually convert one form of the equation to the other form. Perfect.
Yeah. Got it.
So that gives you, in short, the idea about what are parametric equations, symmetric equation, Cartesian equation. How do we
Yeah.
derive and understand the Cartesian equation itself? Correct?
Yes,
So,
sir.
so that is something which is very important to understand. And now we need to figure out that why we do not have Cartesian equation in R3.
Yeah.
So if we, in 2 dimension, perpendicular to this is one line. Do you see that one line, correct?
Yes, sir.
But if I'm considering a line R3, then perpendicular to this will be the whole plane. Do you see that paper?
Yeah.
So the Cartesian equation in R3 will represent a plane, not just one line.
Oh, okay. Yeah.
You see this plane, the paper or the table or whatever.
Yes, sir. And
That's
in
the
R3, we'll also have an extra parameter.
ABC, XYZ,
ABC.
yeah, XYZ,
Yeah, yeah.
yeah. X, ABC, and then I'll write D there.
Right.
Okay. What I'm trying to say here is, but as soon as I use that extra parameter,
Yeah.
instead of a line, perpendicular to this will now be a plane, not a line.
Yeah.
And so that equation will represent a plane, not a line.
Yes, sir. Got it.
Do you see the visual look into this?
Yeah.
And the derivation for a plane equation is also similar to what we did just now. Is it? But you learn it later. Is it okay?
Yes, sir.
Perfect. So that is what it is. Let me give you one very important formula, which will help
Yeah.
you find this. Now we know that we know this line, right? Let's say
Right.
we have written this line. Now, okay, let's look into this line a bit more. So from this line given in Cartesian equation, we can always find the normal, correct? So we know normal is AB, right?
AB. Yeah.
Slope is
B minus A.
okay, x-intercept and y-intercept. You can also get those values directly from here, right? X-intercept means y is 0. So minus c
Right.
by a, right?
Right.
And the y-intercept will be,
Minus C by B.
you see that. So from the Cartesian equation, you get all these parameters. Once you get all these parameters, it is very easy to graph this particular equation. Do you see that? Because you got those x and y intercept, right?
Right.
Does it make sense to you?
Yes, sir. Makes sense.
And now, if you look into it, we'll learn in next class that we can actually find the distance of the line from any point, even from the normal. Do you see from the origin?
Right.
Because if we find this point of intersection, in that case, we are in a position to find the distance of the line from the origin itself, right?
Right.
Well, I'll give you the formula. Distance is always positive, and therefore this distance d is equal to whatever is this a and b value, because a and b values define the normal, right?
Right.
So it is square root of, oh, sorry, uh, absolute value of, let's say point is x1 by 1.
Yeah.
So in general, this is from 0, but I'll tell you from any point x1 by 1, right? Let's say this is point x1 by 1. Then we know
Yeah.
this x1 by 1 shortest distance will be along the normal only, right?
Right.
Correct. So that normal plays a good role because we can find the shortest distance. So it is
Right.
equal to ax1 plus by1 plus c over square root of a square plus b square. As you can see, when I divide by square root of a square plus b square, it actually gives me a unit vector along the normal, right?
Right.
It gives me the unit vector along the normal. And therefore, from x1, y1, it's kind of a projection, which we're
Right.
looking into and finding this distance, correct? So the
Yes, sir.
concept of projection which you have learned can help you find the distance. And the formula is right there before you. Is that clear to you?
Yes, sir. Clear.
Correct. So let's take a few examples. Clear. So let's say some equation 2x plus, let's say 3y minus 12 equals to 0. Now, can you find distance from origin?
Yes, sir. We can just use the formula, right? One we just spoke about.
Yeah, tell me.
Right. So if it's from the origin, then our point would be 0, 0, right?
Correct.
So that would be our x1, y1. So then we can do 2 times 0, and then, yeah, it'll just be minus 12, just a constant. And then
Correct.
square root of 4 plus 9.
Correct. You see that?
Yeah.
So 4 plus 9 is 13, right?
Right.
So that's your answer. So you see how easily we can actually find the distance of the line from the origin, right?
Right.
If this was some other point, let's say the point is, let's say 3,5, let us say, right? In that case, distance from point 3,5 will be what? So like 2 times oh, sorry, 2 times 3 I wanted to write. Plus 3 times 5 minus 12 over square root of 2 square plus 3 square. Is that clear to you?
Yes, sir.
Absolute value, it has to be positive, right? So again, you can do the calculation. 6 plus 15 minus 12 plus 13. So 3 9 over square root.
Yeah.
Correct. So you can easily find the distance of a point from the line using this particular formula. Is that clear?
Yes, sir.
Perfect. So with that, we come to an end on this particular section of
Yeah.
understanding what is Cartesian equation of a line and how does it relate to all other equations we have studied so far in R2 or in 2 dimensions. Is that clear to you?
Yes, sir. Clear.
Okay, now I'd like you to summarize our learnings and then we'll see some videos and some questions from the YouTube channel. Yeah, can you summarize
Yeah.
what did you learn today?
Yes, sir. So today we went over the Cartesian equation of a line in R2, and we mainly touched upon how to really convert from one form to the other and saw how like 2 or more forms are interrelated and how we can go from one to another really quickly. And I think like when solving application problems, this will be really, really useful because like sometimes I predict that they'll give constants and then we have to find the value, right? So I think it'll be helpful in that case.
Yes, yes, yes. So let's take some examples from my YouTube channel. So can you on your computer just search for Anil Kumar?
Yes, sir.
Equation of line. Let's say Cartesian equation of line.
Yeah. I'll just share my screen.
Yeah.
You can see, right, sir?
Yeah. Okay, you can click this one, part 4, Cartesian equation of line, 40 minutes video. So there are many those videos where we have discussed different types of questions, right?
Right.
Now, this is a long video, which is kind of a lesson, just as I have taught you just now, okay? So you
Yes.
can, in between, just click somewhere, we can discuss. We're talking about connections with intercepts and normal. You know now the connection between intercepts and normal, right? So
Right.
if I'm given an equation ax plus by plus c equals to 0, as you can see, the slope is, in this case, 2x minus 3y plus 6 equals to 0. When you rearrange into slope-intercept form, you get the slope. And when you flip and negative reciprocal, you get the normal. And so you realize that A and B correspond to the normal to the line, correct?
Correct.
Now you can click somewhere ahead, a bit more, yeah. So that is the basic concept which we learned today, how normal axis is unique in a way that it is from the origin, but towards the line, so that the dot product of this normal vector with the slope of the line is 0. So they are perpendicular to one another. That helps us to derive the equation, basically, right?
Right.
Okay.
Yeah.
So move forward. We also took those P and Q points and did the same. And now here's your first question. Can you please read the question and answer?
Yes, sir. Determine the Cartesian equation of a line with a normal of 4, 5 passing through the point A minus 1, 5.
Correct. How will you do it?
Right. So, sir, if the normal is 4, 5, then they gave us the values of A and B.
Correct.
So we can fill that in, right? It'll be 4x plus 5y plus c. And now just sub in minus 1, 5 and solve for c.
Yes. Equals to 0, and then you find the value of c. Correct. So when you put that equal to 0, you can find the value of c. And so once you have the value of c, you have the equation of line. Correct? Move forward.
Yes, sir.
Question number 2. Can you please answer this question?
Yeah. Determine Cartesian equation of the line passing through points minus 3, 5 and minus 2, 4.
Correct. How will you do it?
Sir, first, I think I'd find the slope between these two lines, right?
A and B, correct.
And then since we know that the Cartesian equation's form is AB, which is the normal, I'd find the perpendicular to that, right? So in this case, it'd be positive 1, positive 1.
Correct.
And then after, I'd equate it to 0 and solve for C the same way.
Perfect. Using any one of these points, correct?
Yep, right.
Let's see the next question. The very good video, which gives you not only derivation of the formula, but give you some practice test questions, right? Next question.
Right.
Can you please read and answer?
Yeah. Determine Cartesian equation of the line perpendicular to 2x minus 4y plus 7 equals to 0 that passes through the point A 7, 2.
How will you do it?
Right. So, sir, we know that this vector would be 2 and minus 4, right?
Yeah.
So perpendicular to this would be 4 and 2.
Correct. 4 and plus 2. Yes.
Right. So that'll be our new Cartesian equation. And then same thing, we plug in 7, 2, solve for C.
Perfect. Very good job. Next. So it's quick, right? So you can actually review it pretty fast with some test questions. These are real test questions, okay?
Yes, sir.
On this particular topic. Yes. Question number 4. Can you please answer this question?
Yeah. Given lines 2x minus 3y plus 6 equals to 0 and 4x minus 6y plus k equals to 0, explain why the above lines are parallel. For what value of k will the lines be coincident?
Yes. How will you do this?
Right, sir. So given these lines, right, for them to be parallel, they should have the same direction vector in this case, right? So the direction vector for this is 2 and minus 3. And this
Normal
is just
vector 2 and minus 3 is a scalar. Yeah.
Yeah, scalar multiple of 2x minus
2 and
3y,
minus.
right?
Yes.
That's why they're parallel.
Correct.
And for what value of k will the lines be coincident?
Yes.
So coincident means that they're touching, right? The lines?
Same lines means they have the same y-intercept.
Oh,
Right.
okay. So then I can take a point from here.
C
And then,
should be same.
right,
The
C
same
should be,
normal. Yeah.
right.
So when you use scalar multiple by 2, so 2x minus 3y plus 6, if you multiply that by 2, you get 4x minus 6y plus 12. So k has to be
Right.
12, right?
12, right.
Yes. So they are parallel. You could equate any points. C could be a good point, right?
Yeah.
Next question. It looks simple when you understand all the concepts, right? Now,
Yes,
this
sir.
question, how will you do this?
Write Cartesian form of following equations.
Yes.
Y equals 2 over 5x minus 3. Right. So I just multiply on both sides by 5. So.
Correct. Rearrange.
And then bring everything to one side and equate to
0. Yes, you got it. And second one, how will you do this?
And in this case, sir, they gave us the symmetric form, right?
Yes.
So our vector would be 2, 5, the direction vector.
Yes.
And our point would be 1 and negative 4, right?
Yes.
So I think our base would be 2x plus 5y plus c is equal to 0. And then we can plug in 1 and minus 4 to solve for c.
Perfect. Or you could just cross multiply and rearrange the equation.
Right. Yeah.
So you do 5 times x minus 1 equals to 2 times y plus 4. Rearrange, put them all on one side equal to 0. You get the Cartesian equation directly. Is it okay?
Yes, sir.
Perfect. Next question. Yeah, can you please answer this question?
Yes, sir. Find the angle between the pair of lines x minus 3y plus 6 equals to 0 and x plus 2y minus 7 is equal to 0.
How will you do it?
Right, sir. So we know that the normal for this would be 1 and minus 3, right?
Correct.
And for this, it would be 1 and 2.
Correct.
And we know that cos theta is equal to the dot product of these two divided by their magnitudes multiplied, right?
Correct. So you'll use dot product to find the angle between the two normals. And that will be same as the angle between the two lines, correct?
Correct. Right.
Correct. Next question, please. Can you please read this question?
Yes, sir. The lines x minus y plus 1 equals 0 and x plus ky minus 3 equals 0 have an angle of 60 degrees between them. For what value of k is this true?
Right.
Right. So this follows the same concept, right? Concept. Dot product.
Yes.
Yeah.
Great. Next question.
Write Cartesian equation of a vertical and a horizontal line passing through the point P.
Correct. How will you do this?
Right, sir. So for a vertical, the equation of a vertical line is just x equals to 3 in this case, right?
Yeah, yeah.
And then for the horizontal, it would be
What
y
is
equals to,
normal? Yeah, that's correct. Your answer is correct. So what is normal to a vertical line?
sir, it would be the horizontal line, right?
Yeah, so normal will be, you can say 1, 0, right?
Right, right.
And normal to a horizontal line will be 0, 1. You get the idea? That
0,
will
1.
also help you to get the equation. You 1, 0, 0, 1 when you write,
Yeah,
right? And find the value of C, you will get y equals to that and x equals to whatever, both the
yeah,
equation. You get the idea. So it is
yes,
better
sir.
to use the concept to get your equation rather than your earlier concepts. Is that okay?
Yes, sir.
Yeah. Answer in any case, both will give you the same answer. Okay.
Yeah,
Next question.
yeah, I think that's the end of it.
That's it. So we had 8 questions, which easily you could solve on this particular topic. So that means you have really understood this topic fairly well. Is it okay?
Yes, sir.
So explore more and you can do some more practice questions from your book. If there's any difficulty, we'll look into it. Perfect.
Yes, sir.
So we can end the class with that.
Yeah.
So overall, any difficulties? You've understood the topic completely?
Yes, sir. I've understood it completely.
Very good. So, okay then, Akshit, have a great day. You can look into some more questions from your book or my videos
Yeah.
that we'll discuss further.
Okay, sir. Sounds good.
Thank you and all the best.